While the project you'll be making in this course is based in full daylight, light nodes are really fun, so I wanted to tell you how they work. This will also be perfect if you decide you want to create a cave level at a later point. If you've had a look through texture resources before, you may have come across some of these bluey pink textures before, and had wondered exactly what are these things. These are files commonly referred to as bump maps or normal maps. Their purpose is to give additional detail to objects in a more efficient way than adding to the polygon count. It's a trick that is graphics resource friendly and can really look good when used properly. This technology originated with 3D models, but can also be used in 2D assets, which is what we'll be looking at with the SK Light node. So how does the normal map work? Well, first you have the texture of your sprite. The normal map acts as a texture layered on top of your original sprite texture. This texture normally isn't visible though. It will only appear as a clear layer. This is until you make it react to a light source. That's when you'll see shadows generated from the normal map and points of brighter lighting over the top of the original layer. As your light source moves, the texture will update accordingly. Okay, so what does this bluey pink image actually mean? Well, first let's consider a height map. A height map is a grey image where the midpoint between white and black is considered to be point 0. To explain what I mean, imagine a 3D model that is just a regular cube. If the height map for one side of the square was black, then it would appear to have a dip in the side. If it were white, then the square would poke out of the original object. If it was a grey colour in the middle of white and black, then it would be exactly level with the side of the cube. You can also have any variation of levels between white and black, and they will appear accordingly. I was going to make a 50 Shades of Grey reference, but I think you get the point. Okay, so back to normal maps. Normal maps are a lot like height maps, but there are a few differences. Normal maps use RGB, or red, green and blue, color codes to determine a few things. In RGB, each value is between 0 and 255. These values determine how much of a color is in the color being displayed. So each individual pixel in the image has 3 of these values between 0 and 255 to represent your reds, your greens and your blues. The RGB values in a normal map means something a little different. They represent the X, Y and Z coordinates. This allows you to take a 2D image and determine where it intrudes and extrudes for each individual pixel to view it in a 3D space, or add more detail to a 3D model without adding complex vertices. I should probably remind you now that this doesn't actually make the image 3D. It just tells the light rendering engine how it is meant to react with the surface. On 3D models, it does a little more, but for your 2D sprites, this is all you really need to know about it. So going back to your RGB values, I said it represents X, Y and Z coordinates. The blue value, which is the Z axis, works just like your height map, but instead of being shades of grey, it is different levels of blue. If you remember the middle grey colour representing the point 0 with the level of the object that it is overlaid on, that's the same with normal maps, so the middle blue value is used. This is why most normal maps have so much blue in them. If the normal map was just a flat image, then this is what it would look like. So that's the Z-axis. What about the X and Y? These values work differently in different lighting engines, but the X-axis is always red and the Y-axis is always green. Together, these values tell the lighting engine which way the face for this pixel is aimed. So if your light source is in an opposite angle you will see a shadow. If it is in the same direction as that angle, then it will be fully lit. The math that the light engine uses to do this is really interesting if you have the time to look into it. But I hope by now you have a rough understanding of how normal maps and bump maps work. Now it's time to talk about the lighting itself and how it can be used with normal maps to enhance the quality of your lighting.